services are indispensable in the search for oil and gas. Known as wireline services, they are provided to the oil industry in more than 70 countries around the world. Operating from mobile laboratories and trucks on land and rig-based units offshore, logging company crews measure the physical properties of underground formations, using sensors to measure electrical resistance, sound travel time, and nuclear properties. Because of the important information they have provided since well logging technology was introduced in 1927, these services have become as vital to the exploration and production of oil and gas as the X-ray is to the practice of medicine. It is generally accepted that oil and gas are formed from the residue of plant and animal life and are accumulated in porous rocks such as sandstone and limestone. Some of these geological formations contain reservoirs of petroleum in commercial quantities. To find these reservoirs, it is first necessary to locate geological areas where oil-bearing formations may be present. Seismic testing, shock waves, gives preliminary indications of structures which may contain oil, but there is no reliable way to precisely evaluate these subsurface structures without drilling. When a well is drilled, evidence at the surface is often inconclusive that the drill has penetrated an oil or gas reservoir of commercial value. To get this essential information, the drilling is interrupted periodically so that a well logging company can be called in to the well site to lower various measuring instruments to the bottom of the drill hole on a line of wire-wrapped electrical cable. Hence the term wire line. As each instrument is pulled out of the hole, it measures the depth and physical properties of the various formations it passes. These measurements are transmitted on the wire line to a recorder in the mobile laboratory. The recorder, in turn, produces a graph called a log. It shows a complete picture of subsurface formations, how deep, how thick, how porous, and the oil and gas content. This log is essential to the determination of oil reserves, location, and quantity. Also, wireline logging services are indispensable for evaluating the production potential of a well and establishing the location of future wells. The vast scope of information required and the wide range of formation and borehole conditions encountered rule out the possibility of fulfilling the requirements of well logging by any single survey. Two or more logging services are normally used in a modern logging program, either individually or in combination. The basic objectives of well logging are, first, to locate oil and gas reservoir formations, and second, to determine the amount of oil or gas present in the reservoir. Also, the logging program provides data for subsurface structural mapping through correlation with logs of other wells. Logs identify the characteristics of the rock formations. They pinpoint depths and thicknesses of production zones. From the logs, the formation porosity and the hydrocarbon saturation may be computed. Service company crews are specifically trained for the complex business of well logging. The engineer in charge of the unit and crew has been trained to run the services, interpret the data, and to act as a consultant to geologists and petroleum engineers. The logging units use steel-wrapped, multi-wire electrical cables. The instrument is lowered into the borehole on this cable. The cable transmits signals between the downhole tools and the surface control panels. The cable also provides the means to measure the depth of the well and the formations. The electrical power to operate the logging unit's equipment is supplied by a generator. The normal logging procedure involves lowering a tool to the bottom of the well, and to record the characteristics of the formations on a continuous piece of photographic film as the tool is pulled up. Inside the steel housing of downhole tools are complex electronic circuits. The housing protects these sensitive components from the drilling fluids or mud in the well. The control panels for the tools are located in the instrument cab of the mobile lab. Film is loaded into a recorder, which is a type of camera. The recorder prints the various measurements on the photographic film. The film is developed in a small darkroom immediately following a survey. The log resembles an electrocardiogram that you may have had from your doctor. On-the-spot field prints of the log can be run in the log printer that is also in the instrument cab. Geologists know that many subsurface formations are porous. They know that when oil is discovered, it will be found in the small pore spaces present in a formation. Some formations have a very small percentage of pore space. These are said to have a low porosity. Other formations contain a relatively large amount of space that is void of solid material. These are high porosity formations. If the pore spaces are interconnected and are large enough to permit the flow of a fluid, the formation is said to be permeable. For a formation to be productive, it must be both porous and permeable. The formation porosity may be considered the available storage space. Thus, the amount of fluid present in a formation will depend upon the formation porosity. The formation must be permeable to permit the fluid to move, or flow, to the well bore and up to the surface. Wireline logging provides reliable information on the porosity, permeability, and other characteristics of subsurface structures. To get this subsurface data, electrical, acoustical, and radioactive properties are measured. Rocks and hydrocarbons have a high electrical resistance, but salty formation water has a lower resistance. An electrical current is made to flow in the formation, and resistance to current flow is measured. The resistivity measurement, combined with other surveys, is the primary method of identifying hydrocarbon content. In a sonic tool, high-frequency sound is emitted from a transmitter at one end of the tool and detected by several receivers elsewhere in the tool. The time it takes for sound to travel over a constant distance can be related to formation porosity and other geophysical properties. Porosity defines the void space in the formation, which may hold liquid or gas. By detecting natural gamma rays emitted by formations, shales can be distinguished from sands and limestone. Other tools use radioactive sources to introduce neutrons into formations. The resulting emissions reflect porosity by indicating the amount of hydrogen present in the formation. Another tool, which emits strong pulses of neutrons, measures the return flow of gamma rays resulting from changes in the atomic structure of the formation. Most radiation measurements can be made through well casing, and they're the primary diagnostic tools for remedial work on older wells. A tool which sends gamma rays in the formation gives an indication of formation density, hence porosity. The dip meter survey provides information on the angle, or dip, of the various layers or strata in the formation. Information gathered by dip meters helps overall reservoir analysis. In many cases, a dip meter analysis of one well may assist the geologist to determine where to drill the next well. Dip meters use multiple resistivity pads combined with inclinometers to measure the direction and angle of formation dip. Other wireline services include taking samples of formations and downhole fluids, and recording surface measurement of downhole pressures. Once oil or gas has been located, a steel casing is cemented from the surface to the bottom of the hole to avoid a cave-in and to keep water out of the hole. The well is then prepared for production by perforating the steel casing at the depth of the hydrocarbon reservoir by means of special explosive charges shot from a gun on the end of a wire line. As wells start to age, production declines for numerous reasons. Log diagnosis can point to remedial action, such as recompletion, to produce from other zones in the well, or stimulation to reawaken an old well. Here again, wireline logging tools enter the picture in the search for hydrocarbons. It is not enough to accumulate data. Expert interpretation is required. A quick review of the log at the well site is made by both the customer and the logging company's engineer. Often this results in the immediate running of another, more specialized log to pinpoint a promising zone. A new integrated system of surface instrumentation built around a computer inside the logging unit provides speed and flexibility unattainable with conventional systems. With this computer-controlled logging unit, logs from several services may be combined and computed immediately at the well site for timely answers and decision-making. For more sophisticated computer processing and analysis, various logs run on the same well may also be interpreted with the aid of a more powerful computer at a computing center. Data imprinted on magnetic tape while the logs are being run is sent by telecommunications to the computing center. Oil field wireline equipment must withstand the shock and vibration of transport by land, sea, or air. The salt spray offshore, and temperatures ranging from the desert to the frozen Arctic. Downhole tools must withstand the pressure cooker environment of the well, where the operating temperature may be 500 degrees Fahrenheit, and pressure may be as high as 20,000 pounds per square inch. Under these conditions, normal electronic components and insulators fail, and plastic materials melt or burn. Also, downhole tools often encounter corrosive conditions which weaken the hardest metals. The wireline itself must withstand corrosion. And to ensure accurate depth measurement, it must withstand the stress of both weight and winch tension. Downhole tools contain the most sophisticated electronic components available. It is the equivalent of squeezing a high-precision oscilloscope into a 4-inch pipe, then expecting it to work perfectly while banging it with a hammer and boiling it in acid. Such equipment cannot be bought off the shelf. It must be designed and manufactured by the logging companies. Only they have the technical experience, knowledge, and research capabilities to produce this equipment. Each year, the companies spend millions of dollars to produce wireline service equipment. Even the trucks, the land-based mobile laboratories, are custom-built by the logging companies. New services result from constant research and development programs aimed at providing the petroleum industry with new and better answers about subsurface geology. The success of these research programs is illustrated by the fact that over half the logging operations performed today utilize services that were not available 10 years ago. Hundreds of field offices in North America place logging services within a few hours of every active oil area. The services are available from each field office 24 hours per day, 365 days per year. Where drilling is on land, trucks handle the assignment. When the search for oil goes offshore, the wireline service company installs some of their equipment on the rig and transports the crew and other equipment to the rig by boat or helicopter for each logging job. When the drilling crews work in inland waterways, wireline services are provided with barge-mounted units. In simple terms, we have defined the terminology used and have explained the technology involved in providing wireline services to the oil industry. There are many other essential features to wireline operations: quality of service, integrity in handling confidential information, the field engineer and crew, their continuous training, all essential to a highly technical service business. The diligence and skill displayed by wireline service company people in the field, at the manufacturing plants, and in the research laboratories have made these services an indispensable part of the petroleum industry. It is largely to the logging services that the industry looks for information upon which to base drilling and production decisions. Thus, the petroleum and well logging industries are inseparably bound together. The future of well logging companies closely parallels that of the industry they serve. The answers they provide and their efforts to serve the interest of their customers have rightly earned for them the title, the eyes of the oil industry.